Hello, Facebook fans and YouTube fans of DX Engineering. It's Friday afternoon here in the Eastern time zone of the USA. It's time for the weekend special. Here at K3LR, we're thinking about 160 meters. This is the big 160 contest weekend, the CQ Worldwide 160 meter CW contest. And this is a chance for operators all over the world to work as many stations as they can in as many states and as many countries. And there's going to be a lot of activity on 160 meters. I was on 160 meters last night and the conditions were very good. I thought it was outstanding. The static was pretty low. 160 meters is much better when it's in the winter. That causes the static levels to come down. So this is a really good time of the year in the Northern Hemisphere to be on 160 meters. And even if you are a slower CW operator, you can still work lots of stations. The slower stations tend to stay higher in the band. So you'll find stations all the way up to 1.9 megahertz this weekend for the 160 meter contest. Now, getting antennas that work on 160 meters can always be a challenge because they have to be longer. The full-size antennas have to be longer because 160 meters is a long wavelength. And so it takes a little bit of work to get a good signal on the band. But you can have fun with just about any antenna. And so I want to talk about some of the receive antennas you can use to be able to receive better. And from a receive standpoint, the challenge can always be, to try and get away from noise or maybe QRM. A lot of guys have had success using antennas that are meant for other bands. For instance, I hear all the time that guys who have a 2-element 40-meter beam, that's a very good receive antenna for 160 meters. The idea is to try what you have. If you've got a tri-band or a vertical that only goes to 80 meters, try using that as a receive antenna. Now, it's not always going to work as a transmit antenna, but a lot of the challenge is hearing on 160 meters. One of the antennas that has become popular here recently is known as a Beverage on the ground. And this is the Beverage on the ground. Let's see. Have the Beverage on the ground. Oh, guess we lost the Beverage on the ground. Oh, I know what happened. Yes, this is the Beverage on the ground here. This is where this website talks about the Beverage on the ground, and they have the box to do the matching. There it is. There's the Beverage on the ground. And so it is a single piece of wire that is laid on the ground, and that's a little different than the standard Beverage. And remember, it's called a Beverage antenna, not because it's something you drink, but it was invented back in the early 1900s by Harold Beverage. And he actually patented this antenna. And of course, the patent has long run off, but it's a very simple antenna that is typically a Beverage is 8 to 10 feet off the ground, and popular lengths are like 580 feet or 880 feet. But it's almost all the time how much can you have, and of course the signal comes in where that resistor is. That's the front of the Beverage, the front of the antenna. And you can see here you put a resistor to ground, and then you have a 9-to-1 transformer because it's about 450 ohms to match to your 50 ohm coax. And so this is a really good for learning about the Beverage. Greg Wardy, W8WWV, who's a good friend of mine, has done a lot of work with Beverages, and so he's got a lot of interesting models and discussions about Beverage antennas. And a Beverage on the ground, you just don't have it elevated. It's just on the ground. And so in that case, you need Here's Beverage on the ground antenna wire from DX Engineering, and this is very popular. And this comes from KD9SV. He also has a Beverage on the ground antenna transformer. So this is the matching transformer that we just talked about. This is you hook one side to ground, and one side goes to the antenna, and you're off and running. And it's that easy. And of course, this uses a popular 75 ohm connector. The F connector can be used for the Beverage on the ground. So these the KD9SV products are available at DX Engineering. And so you get the idea. Now here are some other antennas. This is the inverted L, and this is a very good antenna. I used this at another QTH that I lived at. I had an inverted L, and it was very simple to put up. I put up about 30 feet alongside the chimney, and then I threw the rest of it over a tree. So that 100-foot piece was just thrown over a tree. And at the feed point, I hooked the coax right up to it, and I had 3 quarter-wave radials laid on the ground. And the match was excellent, and I worked all over the U.S. with this. So very, very effective antenna. And so here you see the inverted L, and the more radials you have, the better this will work. But there's not a lot of critical lengths to this. You can make the vertical piece as long as you can, and then the remainder is just the horizontal. And there are a ton of stations using this for receiving and transmitting on 160 meters. So, and here's some other ways of doing the feed points, etc., for the inverted L. And just Google inverted L, and this page comes up. And then here's another page that I found very interesting. And here are 22 different wire antennas for the 160 meter band. And this is on the topbandhams.com website. And so there, you can see here's another derivative of like the inverted L, which is a random length wire, and then some counterpoise radials with an antenna tuning unit. Here's would be a full wave loop, and it does take a 75 ohm matching section. Here's another wire antenna you can use for 160 meters, a third of a wavelength and then a sixth of a wavelength. And here's the full wave loop antenna. This one is up 50 feet. You know, because of the frequency, it's pretty long, but it is a full wavelength long. Here's an off-center fed dipole, or the Wyndham, terminated sloper. This would be a receive-only antenna because of the resistor involved. Here's a double extended ZEP, and so that's 2 5/8 waves. I've used this antenna here at K3LR, and that worked really, really well. A short dipole, and here's another interesting antenna. The multiband Z uses an antenna tuner, and the half sloper, I've used this in the past. That works pretty good. So there's a lot of different ways to get on 160 meters. The curtain ZEP antenna. Here's a capacitance loaded vertical antenna, where you take the open wire and actually short it together and put a capacitor in series. Here's that inverted L again. Very, very popular, very easy to make. You can make it with stuff that you can buy at Lowe's or the Home Depot. So that's on topbandhams.com, and a great place to find out lots of information about 160 meters. And so just wanted to kind of get you all jazzed up. If you're going to think about operating, if you've never been on the band before, it's a great time to go and try your hand at 160 meters. And if you missed the propagation summit, it is available on the DX Engineering YouTube channel, and you can watch all 4 hours. It was excellent presentations from 4 speakers, the Contest University Propagation Summit. Of course, we're busy working on Contest University, which will be held in May, and we'll have more information as we get that finished up. So just wanted to get you excited about 160 meters, and whatever you do, get on the air, get on 2 meters, get on 10 meters, get on the air and talk to somebody, meet some new friends, and get reacquainted with some old friends. And if you need any help, we're here at DX Engineering, and give us a call or send us an email. We'd love to help you have more fun with the best hobby in the world. So for the weekend special, 73 from DX Engineering.